Richard, it's a pleasure to have you finally on the podcast. We've
Yes,
been corresponding for a while now, but
two
we've never
years.
had the opportunity to talk. Yeah, it's been already 2 years. So it's a real pleasure to have you on the podcast. How are you today?
I am very fine, thank you. So, well,
And it's
happy to be here.
awesome. And I understand you are in Texas, in the US, and it's late Wednesday, around 11 o'clock
June,
at your
June
end.
5th. June
Yeah.
5th on our end.
So
And
finally a quiet time at the house, is it?
actually, this is the time when I get everything done because nothing disturbs me. And most of
It's a
these
great
things that
time for.
everything we have to do and the kinds of things that you teach, all has to happen. It seems like after midnight when there's time to think.
The quiet, best thinking time. Well, would you like to take a few minutes and tell us about yourself, a little bit about your background? You are a teacher and a maker, so it's a great combination where I come from. I really like people like that. So tell us about you.
Well, actually, for the past going on 3 years, I've been teaching full time at Richland College here in the Dallas-Fort Worth area as part of the Dallas County Community College system. And our specialty is computer information technology. And we teach electronics technology, network engineering, digital forensics, cybersecurity, and a number of other things, basic operating systems, A+ type curriculum. And within 2 years, students can come in from ground zero, have an associate degree, and essentially they have a degree that they can get a job. And I've been teaching in an adjunct capacity for almost 20 years at the college, and most recently full time. But before that, I was in public education, primary school and high school, and teaching technology education. And basically, that could range anywhere from some electronics technology, languages, ActionScript, Scratch, to teach a little bit of programming. Uh, Another program we have here called Project Lead the Way, which is engineering preparation, and teach, once again, electronics and robotics. And I had when I was in middle school teaching there for about 3 years, we had a champion robotics team, and we had eighth graders that were very, very bright, and they could do robotics, and they were competing. Well, we won on state level, so that was a lot of fun to do that. So I've been doing that, and then prior to that, I've been in some sort of teaching capacity, but I got into teaching when actually, it's after the .com boom. I don't know how the year 2000 affected Down Under, but Richardson is what they call a layer 2 town, and that means everything has to do with bandwidth, and everybody was investing in bandwidth architecture in 2000, and I was with Cisco Systems at the time, and then all that bandwidth had no place to be used. All those things
Waiting
were
for you
not,
to.
if you recall that time. So what
Yeah,
happened,
but
companies like MCI evaporated, Northern Telecom evaporated. They weren't too far from our house, and consequently, I was part of the 20% or 25% at Cisco Systems that was made redundant. And so I took, the last thing I recall, I was the academy manager for the Cisco Networking Academy at Cisco, and I finished my Cisco certification for instructor training because I wanted to see what we were asking instructors to do as a manager. And so I finished my training on a Saturday. I was made redundant on a Monday, and I started a college teaching job about a week later.
oh man,
And so I had a
no time
certification. I
to
thought,
waste.
well, so it just worked out beautifully. And the beauty of it was I did not have to travel 80% of my time,
Yeah.
which is just incredible because we had to cover a lot of area. But before Cisco, I spent nearly 20 years with Apple Computer
Yeah.
doing all sorts of things, but primarily education, and did
You wrote a
the
book.
first, yeah, the first way back when Apple Computer was making a black version of the Apple II computer called the Bell and Howell microcomputer, and that was in education. Bell and Howell got out of the business, and Apple got into the education business. So I started
Ah,
teaching uh, computer literacy with computers, and I thought, well, we should do this correctly. So we wrote a book, and that was probably a first experience into getting into the hands-on portion of computers. It's changed as the user interface has changed over the years, which has affected technology greatly. But in those days, there weren't a great deal of programs. The only viable program that had come out in 1979 was a program called VisiCalc, and I had one of the
yeah.
first couple of hundred copies of it. I still have it, actually. Uh,
So
doesn't run
VisiCalc
on
was
anything.
like an Excel back
Oh,
in the day,
yes,
1970s, right? Like
that's right.
a spreadsheet, perhaps. It
Is
might have been
a,
the first one.
a visual spreadsheet
Yeah.
like Excel, and actually everything I know about Excel today, I learned from VisiCalc then, because the principles don't change at all.
Yeah. It was a killer application for the IBM PC, wasn't it? Like it made the IBM PC a real option for businesses.
Well, VisiCalc actually never made it in a popular sense on the PC, because
Okay.
another product called Lotus 123
Yes, that's right.
actually became the spreadsheet of strength, and then Lotus
Yes.
123 migrated to the Excel
Yes.
spreadsheet and the Microsoft
Mhm.
Office. So that's the way the migration occurred then. But it was a time of great change in those days.
As
So,
you're speaking, all these memories come back
oh yeah,
from.
then the other thing, whoops, something went away here. Oh, okay, yes, I see what you're doing. That's it, yes. Except you have a green monitor, I had a white monitor, and
Sharing my screen. There you
software arts. Well, I don't know if having an original
Yeah.
copy
Can
of
you
it will make
imagine
me rich.
monochromatic green fluorescent on the
But
bookshelf?
VisiCalc
It would be
changed.
very valuable, that's for sure. So,
If I But VisiCalc changed everything in those days. It was one of those paradigm shifting architectures. I was working at Texas Instruments, and I created a job costing system using VisiCalc at Texas Instruments. And before that, job costing had to be done on what they called green sheets, and green sheets were just a pencil and paper way of creating a cost estimate for a training course or some sort of engineering effort that you were trying to sell to a customer. And it would take a full day to do a green sheet. And
yeah.
uh, it was a miserable process, and but you had people dedicated to doing that. Then VisiCalc came out, and I did it on an Apple II, and it took me a couple of weeks to put together a spreadsheet, and I could do 3 different estimations uh, in about 5 minutes.
Yeah.
And so I could take a 3-day job and turn it into 5 minutes.
Yeah.
And
Productivity.
and what happened? The clerks, when my manager would send me home, I carpooled, so he would give me the keys to his car. I'd go home, run off some spreadsheets, bring them back, and he would be able to go to a meeting, and he would. Then he had these spreadsheets, and we could cost things out, and we could do things like we could cost something out for the United States, and then we could also put in a 10-year cost estimate for something that might happen 10 years later in a foreign country, and add in different overheads and other tariff issues,
So the
and
complexity of the sheets increased a
oh,
lot because of the
but it's
capability.
just
Stupid
arithmetic
sheets.
more than anything else.
Yeah.
But the
Yeah.
paradigm shift was, we had people that would take a couple of days to do a screenshot or a spreadsheet, a green sheet. to cost something out, and now they had no job because I could do the whole thing in 5 minutes.
So
And
retraining, I guess back in
oh
those
boy,
days, like the changes in the workforce that are so obvious today, you know, jobs moving across to China from the US and service economies and globalization, all that had started happening with the coming of those new technologies and the PC revolution.
right. So that's how I got on with Apple Computer. Apple Computer opened at one time. All of the Apple computers were manufactured in Carrollton, Texas, which is not too far away. And then all of that eventually moved offshore, which is a paradigm shift with the engineering workforce
And
not being as
manufacturing.
great as it was offshore, onshore. And we the plant closed, I think, in about 1985, 1986, but we used to, I think there was about 4,000 people employed in the area here, and then that diminished over time after the plant closed. But I knew something about a spreadsheet. Apple had moved to Texas. I happened to go to the Apple plant to pick up a product upgrade for my Apple II, and I met the guy that I bought my Apple II from when I was with IBM in St. Louis, and he said, "Are you doing anything creative?" I said, "No, not a thing." Said, I'm back here, and as far as I know at Texas Instruments, I'm in between jobs at Texas Instruments, so I may not have a place to go. And he said, "Well, send me a resume." So I did, and 2 weeks later, I was working with Apple, and
Wow.
because I knew something about spreadsheets. And
Yeah.
so it was just that sort of thing, and then I was able
And
to
that's when you
find
wrote the book,
something.
right? That's when
Yeah,
you
it's
wrote
called the
the
Apple II Primer.
primer.
It was published by Apple, but it was in narrow distribution. It actually got
It
published, but I
was
don't know that it got distributed.
it was like an early. Oh, it was not an early. It was an early. Sorry, an early training manual for teachers. So it was like
Correct.
a teacher could use that book in the classroom to teach programming. Is that what it was about? What
Precisely.
was it? The
Basically,
content of the book?
it was a survival guide for a teacher. It talked about how to format disks, how operating systems work, how
Ah,
to use computer programming. Of course, the programming there was
basic.
basic, and then we also had Pascal.
Yeah.
And actually, there was a C compiler for the Apple II that
Whoa, I didn't know
was
about that.
yeah, it was three guys in an apartment that had done that, and they became very rich, I think. But that was the book, and that we taught that, and that really established Apple in education in those days,
Yeah.
and that was a lot of
I've
fun.
got to, like, this brings back a lot of memories for me as well, because that was the Apple IIe. The Apple
Yes.
IIe was my first computer. My father and my mother bought that for me in 1985. And I still have it. It's in my cupboard. It works. I've got 2 disk drives, a lot of floppy disks, the green screen, the green fluorescent screen, and
Wow.
everything works. I've got an memory extension board. I think I took it to 128 kilobytes
Yes.
of memory. And I've got a dot matrix printer that still works as well. It's just I don't have the tape with the ink, but it still
Yes.
operates. If I can get that, it will print.
I may have some artifacts that might be of use. Uh, I'm trying to think, what do I have for the Apple II? I think most of my software is Macintosh.
Yeah.
But
I've got games, like my kids play my Apple IIe games, Load Runner and
yep.
Firefox, and the game, not the browser, game, by that name. Where in the world is Carmen Sandiego?
Yes.
And lots of other games. I can't remember the names of, but it's amazing how they work after all this time. The media is pretty strong. Keep them safe and dry and cool location.
Right.
But all that brings me, that's how I learned Applesoft Basic was my first
Yep.
language. And I was picking and poking in the RAM
Yep.
locations with assembly language. And, my first contact with computer hardware was my Apple II, because it was an open architecture. As you remember, you could plug things in, remove the case, and remove cables. Like it was a computer that you were not afraid to muck around with. A little bit like the Raspberry Pi, right?
Right. You could take the lid off.
Yes, that's right.
And get into it.
Yeah.
Plug things in.
Which brings me to the Raspberry Pi.
Yes.
Open architecture, right? And I know that you have a lot of fun these days playing with Raspberry Pis. Is also part of the course that you teach at the college. Did you want to tell us about your projects on the Raspberry Pi, both like personal projects, but also what you teach?
Well, right now, I teach primarily network engineering, and we teach the curriculum from the Cisco Academy. And Cisco creates the curriculum and they give it to schools. And I know you have academies in Australia, high schools and college, but it's free to public institutions. And so I've been doing that, and our class loads, I've just been teaching the basic intro for a very long time, simply because that's the one, and simply because it's, we have, well, let's put it this way, not everybody wants to do a career in network engineering, so we'll get very large classes at the beginning, and then they dwindle, or they filter out when we get to the next level, because there is this stuff. I tell my students up front, said this stuff is hard and it's boring, but if you happen to like it, it's not, because you're going to learn how everything works, and that's essentially, you're showing what I'm teaching here. And there is another course, you may see it come across here, that networking programmability is also of interest to what we're doing as well, if you saw that one in here. But I'm developing an IoT course, an Internet of Things course that Cisco has a curriculum for that. There's actually 4 different modules, and I'm going to be doing the one with connecting things, and that's the one that primarily makes great use of the Raspberry Pi and the Arduino boards to teach how that's it. Introduction to IoT is part of it. And then, yes, the IoT fundamentals. But I think the IoT fundamentals can be done in less than 16 weeks. So I'm going to have time to add additional things. So I'm going to actually, a lot of the things I'm going to take from Tech Explorations, electronics technology, the components, the TMP 36 lab from the Arduino is a project I've been working on, simply because I can do a lot of the things that are in the Raspberry Pi full stack Raspbian course, and take the TMP 36 analog temperature sensor and do the things, but it has less overhead, and so I can show things in a much simpler fashion. And some of the things that have just are on the Pi, they're simpler to explain using the Arduino. The Arduino is just a wonderful thing to have around. It's just such an easy thing to work with. So I'm going to expand the course and add different sensors, and I'll probably put in some sort of an abbreviated, that's what I've been working on. That's what a lot of the queries that have been coming back and forth, how things work. But I'm kind of stripping out the Raspberry Pi Raspbian course and doing pretty much the same thing, but substituting the TMP 36. So the project, the way it's working, I took the course that you're doing for the Arduino. It's the first one. I can't remember the full. Getting started, yes.
Getting started, yeah.
Right, and so it's got the TMP sensor project in there, and I can't find anything that's simpler than hooking up a TMP36 to an Arduino board. It is 3 wires and turn it on.
And
The
useful
program,
out of the box.
yeah. And then I discovered something. If I'm watching that, the way you monitor the results of that, you monitor the serial output of the Arduino. And then I discovered, well, if that's a serial output and it's coming out the serial port, it's coming out the USB port, because USB is a serial port. We don't think of it like that,
Yeah.
but in my day when we did everything was called RS-232 serial, yeah, and it had 3 wires, transmit, receive, and ground, and you could monitor anything with that. So I poked around and I found, I knew Unix handled this, and I found somebody that had done a program that simply looked at the TTY ports on the Raspberry Pi or the Mac or the PC or what have you under, well, on Mac, I just did it on the Mac under Mac OS, which is Linux underneath. And I could also do it on the Raspberry Pi, but basically I could monitor the serial port coming into the Raspberry Pi, and then I could capture that data and put it into a string and make a list out of it. And then once I had it captured in a list, I could graph it. Well, then I just substituted the list on the Raspberry Pi, and I used the SQLite 3 database and put the data in there. And then pretty much all I had to do was take all of the modules that you've done. I've not taken it to the full end of the Raspberry Pi Raspbian course, but right now, if I want to put in another module, I just have to go in and edit out the things that deal with humidities, and I can read the stream that comes, stream that's coming in off of the Arduino. And what I discovered that was also interesting with that, the Raspberry Pi Raspbian using the DHT22, that is a digital sensor, and the TMP36 is an analog sensor. And these are things you just learn when you do these things. And the Arduino will read the analog input from the TMP36, but it doesn't work that way on the Raspberry Pi. So I'm using the Arduino coming through the USB port, and I could put in 3 more Arduinos if I'm not using the USB ports, and I could have Arduinos feeding serial information into the Raspberry Pi. But if I could, I don't know if I can show my screen here, but I've got...
hang on, I'll stop sharing mine so you can show yours. So if I understand right, as you are switching screens, what you've done is you've connected your Arduino, which is the node that collects data from the sensor you connected to it, and then it's sending the data to the Raspberry Pi. Then the Raspberry Pi is responsible for either recording it in a database. I can see here your article on SQLite 3 running on the Raspberry Pi, but then you can also use its networking features and send the same data elsewhere around the internet, which is probably a useful thing for your IoT course.
Right. So if I can I show my screen here?
Yeah.
So
there's a button down the bottom called share, and click on that.
Okay, share. Click on share.
Yep.
If I disconnect, just call back. Let's see. There's all of my screens.
Yeah. So you pick the one that contains a thing that you want to show, and it will pop up in my screen.
I need to find a browser here. Google Chrome. Let's see if that will do it. Yep, yes, this one will do it. And here's the Tech Explorations podcast, but there's lab conditions RPI. Cool. And you'll recognize that. There's the 3 hours and 6 hours. And that's all. This is as far as I'm going to take it, simply because I need to start working on some other things. But at this point, all I need to do is edit out the humidities, and your stuff works right in here. And of course, I've altered the cascading style sheets. I've not altered them, but I've added them. I found nice. The skeleton was a little
The other framework that are used for the user interface. Yeah,
Yes,
you can always modify that
it's good, but it's complex.
specification.
So, but this works, and you know, so I've also done a favicon here with an apple in it.
Yeah,
So I thought that was a nice touch.
very
And
nice.
if I go here and just change that to temp. Uh,
Oops.
so I'm using the same names and everything. I've just essentially rewritten and actually edited. I shouldn't say rewritten, but there we go. And I wrote my
There you
own
go.
style sheet
Very
to
good.
do that. And I'm gonna I'm planning on putting all this into a guide, because I would love to use the Tech Explorations guides and use those as my text for teaching this part of the course,
Yeah.
which
But
I think will be worthwhile.
you said in the
But
past, like, sorry to interrupt you, Richard. I was just thinking, as you're saying all that, as you also said in the past, like your job as a teacher is to try and try to teach a fairly complicated topic. If you think about what is involved in all this, it's a
oh,
lot of moving components that need to be able to speak to a lot of other components and standards and, you know, languages and databases, and all those things have got their own peculiarities. But you want to just extract what is important, like the way of thinking, the way that you connect things, the way that you prototype and iterate, and then this is really the core of your teaching. The details can be filled with a little bit of time by the student themselves. But is that how you feel? Because I wanted to ask you, like, how do you approach a task like this, where you have to teach somebody who's never done this before all these complicated topics?
that is a good question. I'm not sure how the class will respond to this, or the students will respond to this. I can take it one step at a time. I know I can start out very, very simply
Hmm.
with an Arduino
Yeah.
and connect the TMP36 and read the temperature, and the number of lines of code on that are minimal.
Yes.
So
No
then,
operating system, nothing fancy, no settings.
don't
Just
have to
start with
load any libraries,
that is the
nothing.
simplest step, the simplest first step.
Right. And then being able to read the data out of a serial port,
Hmm.
we can do that intuitively by just monitoring the serial port with a Python program on the
The Raspberry Pi.
on the Raspberry Pi.
Yeah.
And I'm looking around here. Yeah, and of course I have the Raspberry Pi with the program is on my other computer. I'm on my Macintosh right now. You never have everything in the right place,
That's
but
okay. So is that how you like?
I
I wanted
because
to ask
people are gonna
you.
have to learn how. Go ahead.
I wanted to ask you, like, you're not a teacher. You have multiple hats, and uh, as I've been corresponding with you the last couple of years, I know that you've got you're a maker as well, and you make things, and a
Yep.
learner, like you're a lifelong learner. What is your personal approach to a new project that has a lot of unknowns in it? So the first time that you approached a Raspberry Pi, for example, or an Arduino, how did you go about getting the basics right so that you can go on and do more interesting things later?
This would be a good example. The first thing I did, I actually went through your course and got through the whole thing once, and it worked. And then I did it again, because there's so many different
Yeah.
things working there. But that's a fairly complex course. So try to work with something that works. But starting out, just turning on LEDs and making buzzers beep and reading light sensors and things like that, and just writing a simple program to see how that works.
Simple
That
projects, right?
it's a good place to
Yeah.
start, and then everything else is just a layering activity on top of that.
So
So
once you got those basics right and you started feeling more comfortable with the technology, did you start getting ideas? Oh, wow, I can do this, and oh, I can do that as well. And then you
yes.
started becoming more independent and started
Well,
doing your own projects.
is this a generic term, or is this a term that you all invented? Curiosity driven.
Uh,
That's
I'm not really sure. I
I've
want to
seen it.
think that I came up with the idea, but that's how I felt at the time.
Yeah,
I was something that describes me, like why do I do things, especially around technology. And I thought that's because I'm just curious to know how things work and how I want to poke things and see what my poking effect is. And that's because like the underlying force behind all that is curiosity. So I thought, yeah, I'm driven by curiosity or curiosity driven. But I think a lot
I
of people feel like that, right? And you probably feel like that as well.
that's exactly the way I approach it. You've got to want to do this. This is not necessarily easy, but it's not necessarily difficult once you learn a couple of things. And that's where the teacher comes in. And I tend to not cast myself as a teacher, but kind of as a, what do they call it? A player coach type
A mentor,
position.
perhaps.
Mentor would also work.
I'm thinking the
But
difference between a mentor and a coach. I often talk about this in my boot camp. So, like a coach is like a person of authority that is trying to drive essentially or to guide a student towards a specific goal. So, win the championship or pass the exam, whatever it might be. So, there is some context around it, but I find the mentor really is there to support the student in the student's own journey or own goals. So it's like a facilitator. So that's how I differentiate coach from a mentor. How do you
okay,
feel?
I agree with that completely. Um, it's ultimately it's up to the student to do
Hmm.
the learning. Um, we've forgotten a lot of that with standardized testing and things like that, because I've seen that for 10 years in
Yeah.
public school, and students just need the freedom to explore and find directions and get something to work. And if you can get one thing to work, then you can probably get something else to work. And even though it may just be a stream of consciousness putting something together, once you get to a particular point, you can go back and reevaluate it.
Yeah.
I always tell my students, if you're doing a lab and it works correctly the first time, then it's probably not a very good lab. You should not trust yourself. It's a false sense of accomplishment. Do it 10 times and become consistent with it, and then you'll start to know what's going on. It starts soaking in.
So as a say as a mentor or somebody who is responsible for introducing new concepts to students, uh, your role is a dangerous one in a way because you can't make things too easy because you're going to give your students a false sense of security. Oh, well, this is too easy, or I'm too good, right? I didn't even stress and I managed to do this. But you can't make it too hard either, because if you make it too hard, you discourage people, they just drop off. So you need to be somewhere in the middle. You need to stress the student well enough to show them that even though it is hard, they still have success in whatever they're trying to do without discouraging them. So I'd say introductory courses tend to be very hard because very
Yes.
often it's just a one shot for a student. You can lose them easily.
I try to keep them focused. Uh, the course I'm teaching now is an introductory course. It's the first networking course. There's 4 things you have to learn, and that's all we're going to focus on. We're going to learn
Mm.
a whole lot about a very little, but you're going to do it well, because
Yep.
you're not going to be able to survive if you don't know how to do that.
Yep. Yep.
It's kind of like teaching Vim the first time. What do you need to know? You need to know escape, and
Yeah.
I.
Okay,
and
like,
and
yeah, two things or three things maybe. How to get out of it, because that's where a lot of people get stuck. They can't
right.
they can't exit Vim.
But I also have a Vim book that's 2.5 inches thick back if you want to get into it completely. And so
I'd
they're
say I'm very productive with Vim knowing five things.
yeah, that's all I need. And I work with other things too, but
Yeah.
it works very well. So you don't need to know a whole lot to get ahead. And but that's what got me into electronics originally. I was going to I had never knew that I had an aptitude for this. Well, I
Yeah,
knew I had
tell
an
us about your
aptitude to
early
make
days.
yeah.
Like,
Well, I was in the Navy, and one of my friends was signing up for a correspondence course back when they did correspondence courses, and you actually sent things through the mail, and I could get it paid for on the GI Bill, and I got to build a TV at the end if you finish the course. So it was a neat thing. But the way the sales rep promoted said, I said, it's going to be too complicated. He said, no, it's not. Electronics is not complicated at all. Here's Ohm's law. It's just three things. It's voltage times current is equal to, or voltage whatever.
yeah, voltage resistance,
EIR
current
is what it
resistance.
amounts to. Voltage is equal. I can't read.
Yeah.
I'd have to put my
Voltage
thumb over it and
equals
bring up the triangle.
the
But
resistance times the current.
yes, resistance times current equals voltage. Think about it a little bit. If you're in hardware, it's hard to be in software. I find my mind getting lost in these things and having to reorient myself. But when he explained that, well, that wasn't very hard, and I was able to go through that, and I learned a few things, and learned a few more things, and I was aboard ship, so I had sometimes 16 hours a day to do nothing except study on it, and I took advantage of it. So you can learn this stuff, and it's not hard to get started. Every pioneer in this field, in digital electronics, I was telling my class the other day, Samuel Morse, his background before he did Morse code, he was a contract portrait painter.
I didn't know that.
Oh yeah,
Wow.
that's well, portrait painting. Portrait painting was
What is that?
reaching the end of a career, and
And
digital communications was
yeah.
just starting out, and Western Union was to be founded. So he became very rich as a
Amazing.
result of that.
And
But
if you think
all of
about it, the like back then when you started working with all this, there was no eBay and Amazon and Alibaba
right.
to order parts, right? How did you get parts to build your projects?
Oh well, some of the first, we call it maker things today. That makes sense as a word, but there were always things you could do. But in those days, there was Allied Radio Shack, and Allied,
Yeah.
way back when Radio Shack existed, they were more of an electronics parts store. So you could get things at a Radio Shack store, and I always seemed to get a Heath kit. There was a company that made kits, and some of the things I built as part of the electronics technology course I took my correspondence. The course was had you build some of your components. So I built a digital multimeter that plugged into the wall, an oscilloscope, and then the TV came later on in the program. You had to make it through most of the program because the TV didn't come until the very end, of course.
Yeah.
But it was all of those kits came from Heathkit. And Heathkit, you could get their catalog, and you could build ham radio sets, TVs, radios, test equipment, hobbyist sorts of things, half-watt radio station, an AM transmitter. And I always seem to be getting things like that. So getting the parts and getting the resistors was good. And then one of my neighbors when I was growing up, his dad was an electrical engineer for the energy plant that was in the vicinity, and he always used to bring home batteries and components and things,
Yeah.
and we could do stuff with them, and we made things with them, and it might have just been soldering wires onto a battery, which was not real efficient, but and putting a switch on it and making lights that switched on and off that you could do neat things with. So that was just a lot of fun to do those sorts of things.
So that was your
Yes.
eBay back then, right?
Yeah, and that's a
Something like
modern
that.
one, but
Yeah, it's
Radio Shack,
2011.
I don't know if there's any Radio Shack stores around anymore.
No, they've been sold off, if I remember correctly, and rebranded. It's not the same Radio Shack as it used to be back in the.
No, it was more of it became more of a boutique
Yeah.
and toys. And the Radio Shacks have essentially become like the Pie Hut or the Pie Shop out of Cambridge. Just opened its first pie store. I get the magazines and all of that, and I don't know what you have in. Did you switch me back there?
Yes, I'll switch you
Okay,
back.
good. I saw that up here, and I just hadn't done that yet. But but those you can get components there, and I just got. Let's see. There's my package for an ESP board, and I want to get into that because that looks like a neat component. But that was $10, and ordered it off of Amazon, and it's shipped from China. So and I've got boxes of parts over here, so I needed some NPN transistors, and I was able to get 100 of them for $9.99.
It looks like you're stocking up for some serious project work. What are you planning to do next?
Well, not much, but when you can buy from one company, and some places they might sell 5 for $9, and you can buy 100 for $9.
Yeah, that's amazing. Like another. I call them students, but I don't feel like US students. Like another colleague from Tech Explorations told me about a deal on Alibaba, I believe. You can get 10 ESP32 boards for $50 US. So,
right.
Why not? I'll get 10.
Yes, and they're going to work well. And I have students. Last year I had one student, and he worked with one of the telco companies here. I forget which one, but they were doing projects for some sort of telco monitoring system, but their platform was a Raspberry Pi. And what's the entry level?
The Zero.
Pi Zero, yes, and they were using Pi Zeros.
Yep.
Yeah, because you can get them. Well, if you don't get them free, you get them for about $5.
Yeah,
and they can
power supply for 20.
Yeah, that's amazing, isn't it? So they were doing things like that, but the electronics is cheap. But if you shop around, you can get this. For our course, we're going to go with one of the box vendors. Adafruit and SparkFun are good, but the Cisco curriculum, they specified SparkFun, so we're just going to go directly with SparkFun, simply so I can have a single point of ordering. And if you've worked with institutions, you have to have preferred vendors and
standardization. Totally understand. Deal with returns and problems with hardware. It's totally understandable.
But even then, to put the whole thing together, when I went to talk to the dean about promoting the program, he said, well, what's a kit going to cost? Because one of the things I want to do is give every student, I don't want to give them a kit, but they're going to have use of a kit. They're not going to have to share anything. So everybody will have use of a kit. And I put together kits that would cover all 4 courses. And the kits came out to be about $200. And I thought that was very reasonable. And I mentioned that to the dean, and he said, what's a kit going to cost? It's going to be about $200. I said, well, that's a textbook. And that's what it is, because I got a desk copy. I don't know if you're familiar with the Grobe Electronics Technology
Oh yeah,
text. If
I am.
oh, well, that's the one I used to teach out of a long time ago when I was at Southern Illinois University. But I pulled it out. I have edition 3, and now it's up to edition 12. I mean,
Totally not
where
great.
have I been all these years? So I pulled it out, and when I ordered it, the list price on that was $184 for a
Yeah, textbooks are
textbook.
expensive. It's amazing.
And so
Uh,
we can equip students to be makers for the
how much
price
less?
of a good textbook.
And
And
the context then will be just unlimited with the contents of the kit, the variations of the things that the students will be able to make. It's just wow, almost unlimited.
and he asked, well, what are you going to use for a textbook? I said, well, in the world of STEM, there is no textbook.
Exactly.
There are resources,
The
and
internet.
the internet it's all there, and it's, you know, like tech explorations, and I'm finding everything I need, and I can find books and
Yeah.
things that are downloadable, and most of the stuff is well established in history, so
Yeah.
it's
Yeah.
not hard to find. So
No,
all it takes is a teacher.
exactly, and that's your responsibility as a teacher, like to get all this noisy world, like to convert this noisy world into something with order that students starting up now can, you know, grow into and learn, which is probably the most important.
That's
Growing
a
is
good
learning.
observation there, by the
Yeah.
way.
Yeah, I think that's how I feel. Like every time I start a new course, I'm working on that one now. My first few steps where I try to learn the thing that I'm going to teach is, geez, this is totally chaotic. And no, I'll find curriculums or information. There's bugs everywhere,
Hmm.
incomplete, issues with hardware, libraries, conflicts, and I have to iron out all that. And that
Uh,
was Einstein, the dog.
that's
And um, and that's how I feel it's my responsibility is to just make sense of all that and present it in a way that I can help the student to start, bring them to a level of understanding that the noise is not a problem anymore for them once they graduate.
right.
Um,
Well,
uh,
you use the
yeah.
word noise. I think that's important because so much of what I see for technology or math has to do with a lot of animation and noise, and it's so much entertainment. But uh, your stuff is solid, and the way I don't know if you ever heard of a guy by the name of Don Herbert,
No,
otherwise known as Mr. Wizard.
no, I
Uh,
haven't.
well, 1950s, he essentially did. He was a predecessor of Bill Nye, but he was
Ah, yeah, science guy.
he was a communicator, but he just did things like how things work, and he made things out of junk. And he had a Saturday morning program, and every Saturday morning he would have a helper, a boy or a girl that would help him along, and he would have a half-hour program. They would go through and make something, and I grew up with that. And Don Herbert as Mr. Wizard was famous. If you search on Mr. Wizard, you'll find him. But
I'll
some of
get that.
his
Yeah.
early recordings, they were actually on kinescopes as opposed to videotape. But I've got the video set completely. As a matter of fact, there it is. I've taken it and put it on a flash drive, and I've got the whole thing on a 128 gig, all of his content here that I could pull off just in case I
Ah,
need it.
there you
So
go.
to find, yeah, watch Mr. Wizard. That's it. And he would, as you can see, there's a bicycle tire, and it might be a gyroscope, and
Yeah.
you could actually do a lot of the things that he would do. But if you look at his approach on that, he approached it from very soft-spoken engineering,
Hmm.
science. It wasn't a lot of flashy entertainment and special effects graphics, things like that. It was getting down to what it's making
Yeah. Yeah.
something. And I don't think, well, we seem to, in learning, if you're going to learn this stuff, ultimately you have to sit down where it's quiet and have the time to reflect and see how this goes together, because everything we're doing, there's nothing natural. Everything is has to be learned. The digital world does not
Yeah.
exist in the natural world at all. So
Exactly. It's all artificial. And
yes,
basically, humans create the laws. Well, it's all, of course, you need to adhere to the natural laws of physics, but like how Boolean logic works,
yep,
like how a program behaves when you do something, all that depends on the designer at the end of the day.
right.
The
But
engineer.
anyway, that's what he did here, and I don't think anything is going to replace demonstrating, lecturing somebody actually working through the problems. And when I watch your presentations, you make mistakes,
Yeah.
and
All the time.
I dissect your mistakes, and I can see if it's perfect, you're not telling me the truth.
You should
So
see my new course. Yeah, it's
it's always a
embarrassing.
work in progress. But that's just the way it works, and you've got to stick with it, and you have to do these things more than once. So I encourage my students to do it. I said, and if this is not for you, you need to do something else. But if you want to learn this stuff, it's going to be hard once, and it's not going to be as hard the second time. And after you learn that, once you go on to something new, you're going to find you understand what was really hard is
Yeah,
now part of your learning base, and
exactly.
you understand the project.
Yeah.
So that's good.
Well, I want to talk a little bit about the future,
Sure,
and we'll start wrapping up our
sure.
discussion. It's about to hit an hour. Actually, time flies.
Okay, well, you edited. I'm
So,
sorry. No, I'm
no, no,
thrilled to do this. I'm just waking
it's
up.
absorbing. It is absorbing, and that's why. Well, I looked at the time now. Oh, gee, yeah, it's
Yeah,
good. It's good.
my garage band just ran out of disk space, so
It's okay.
sorry.
Recording is safe. So I know that you're working on a fairly large project now, which is your Internet of Things curriculum,
Right.
Introduction to IoT for the college. Apart from that, is there any other large project that you are interested to work on as a maker, not necessarily to teach something, but something that you would like to learn perhaps? It could be a technology like hardware, it could be software, it could be something that you want to build from scratch, but something that you think is going to actually stretch you, and it will take a little bit more than a couple of days to do. Have you got something like that in your horizon?
Well, not anything that I will probably do until I get this course going
Yeah.
next fall. But I would love to work with the build your own drone
Ah,
type project, because that would be a lot
go
of fun.
airborne.
Yeah,
Yeah.
Gore, yes, and well, you have to do that because I've had two drones, and once they crash, you have to rebuild them, and
You got
it's
to
not.
know what to do, how to do it.
Well, you got to find the part. You've got to find something that has the parts.
Yeah.
If you build your own from scratch, you can always order extra parts.
Yeah.
So
That's a really good project because it, like I found when I was building the drone, it actually got me out of here. This is my lab. I've got my
yep,
back, but it's pretty messy if I remove that.
yes,
But it got me out of here and into a field. Nice sunny day, light breeze. It was actually, I thought, this is really nice. I should do it more often. Charge the batteries, get a few extras. It's a really nice hobby for people that both like the technology and miss the outdoors. So I think you can have good fun there. Good learnings as
oh,
well.
I enjoy playing with just about everything. I'm trying to think what else. I become distracted very easily and wind up doing several projects. But
Of course, yeah.
I've got a C, and yeah, I found a C compiler. I also found on the Raspberry Pi there's an Arduino IDE that you can download.
Yeah.
It's not as
Yes.
nice, but it works,
Yeah.
and I can do this whole course on an Arduino and a Raspberry Pi,
Yeah.
and just plug it
Exactly.
into a monitor.
Yeah.
And the idea is to take the whole course and everything and just fit it into a tote bag, which
Like a portable lab.
yeah, I don't have it in here. It may be in my office, but yes, it's just a a carry-all and about the about as big as a lunchbox, and that's it. And that's everything you need to know to learn everything about engineering. So I think that's
Great.
a good project, and make it cheap, make it inexpensive, and make it to a point that everybody can afford their own lab.
And I think we are there already. If you look at like simulators of electronics online, like that you can run in your web browser, it's amazing what you can do in a web browser these days. So simulate electronics, including Arduinos and digital electronics.
Yes.
The cheap components, mostly from China, Raspberry Pis, open source programming languages, and applications and servers of all kinds. It's like a golden age for makers and for learners.
It's very much like the Apple II days.
Yeah,
it's just like Apple II, because Apple II was very open, and then it became important to have a user interface to make it more acceptable to users, so you didn't have to think about it. But in 1981, every kid had to be able to write a program if you were going to do something.
Yep.
It was in BASIC, because simply because there was no software.
yeah, you got it right. I remember those days, like when I had my Apple IIe, a lot of software was actually distributed in paper in little booklets called manuals, and you'd copy it.
Yes.
It was not on a floppy disk or in a cassette tape. I spent a lot of time copying code. That's how I learned how to
debugging it.
Basic and debugging it.
Yes.
And the messages you get back were just syntax error. That's it.
So you ask about the future. I think the future will be found in the past, and the big difference is the future. Given the way we get components, it's not as expensive, because a Heath kit that did very little, a transistor might have cost $5-7.
Yes,
a transistor. Now I can get 100 for the same amount of money and do something with it. So
and actually, you can sacrifice it easily to see what the smoke is like.
Yes.
Back then, I used to do engineering at the university. We'd go to the lab, and the instructor would give us one transistor each. And if you happen to burn it, like, everybody would look at you. How could you do that? And you had sheepishly go to the instructor and politely ask for another one. Okay, but this is the last one.
Right.
So we don't have to worry about that anymore.
Right. And you can make fund it yourself. But I think that's important, just making everything work in a kit that somebody can afford, that they have complete control over.
Right.
And if you break something, it shouldn't be expensive to replace it.
Not a big deal. Just don't burn your Raspberry Pi. That's a bit more.
Right. Well, yeah, they're $35, but
I've destroyed one in my whole career as an instructor online. I've destroyed one Raspberry Pi, but I've never destroyed an Arduino. I can say that it's a lot more robust, and that's why I think it's a good option for beginners.
I see so much. This is something that always bothered me. I've got a good video on electrostatic discharge damage, and nobody cares about putting boards in cases or grounding them. Just handle it however, and that's kind of a sin.
I try to be careful on camera, but in my real day-to-day operations on my bench, I'm just not very careful. I'm more in a rush than careful, but it's okay.
Well, it's not too hard.
As long as you realize that you're in a rush now, and you can potentially damage the equipment, which I try to be conscious about it. It's okay.
Everything is still working for me, and I've got all sorts of things, and I just get the little boards. And on some of these, let's see if I've got one here. If I can pull this one out. I've got all these projects on these little boards. Let's get in front of the camera here. But that's 3 projects on there, and I just need to wire it into my Raspberry Pi, and I've got it work, or the Arduino, and I've got it working. But it's amazing how small this stuff can get, and you just have projects all over the place. And It just plugs together and it works.
I put them in boxes now because I don't like to dismantle things. I've got like little IKEA boxes, plastic boxes, and I label them. This is for the boot camp. This is for Arduinos. This is boards for
Yep.
ESPs and things like that. So I don't like. It's hard for me to destroy a project.
Yeah.
I think a lot of people like that.
Right. I've got bins of stuff behind me, so I've got, you know, things I like to play with. So I have extra pies, and my biggest fear is that they're going to come out with a faster pie, but I don't think it's going to come for a couple of years yet. Yeah.
Well, Richard, I think it's let's finish our conversation here. It's like 1 hour, so this is perfect.
Yes.
Do you have any thoughts you'd like to share with our listeners? It could be like a piece of advice as an educator or as a maker, or just anything at all you'd like to talk about.
Offhand,
maybe something from your experiences and from your stories back with Apple and the Apple IIe and all that.
Well, I have an Apple Australia story. It takes a couple of minutes to tell.
Yeah.
And when I was with Apple, one of the things that I was able to do, I did the technology planning and implementation for the Apple Market Center at the Dallas, Texas Infomart building. And that was Apple's first public location that people could actually come into and see an Apple facility. And,
like an Apple store.
The Apple stores followed a few years after that. The architecture and the design were much the same, except the Apple stores actually sold things. We didn't sell anything. We were simply a place to provide executive briefings. Right. But bringing it online, we had the Infomart network. And one of the things we did there with the Macintosh, the perception was Macintoshes don't connect to much of anything. They're toys. And Apple went through that phase, as Apple was a different company in 1989 and 1992. Almost became not a company. There's some rough times there. But one of the things I wanted to do at the Infomart was show that the Apple Macintosh or Apples could connect to anything. And so that was my maker project. I simply treated it as an opportunity to connect anything to anything. And we got our entire Apple area connected, but we needed to connect to places like Novell, and the tendency was, or Xerox or IBM, to connect to these other companies. And the tendency was, if you want to show that as a company, you would go out and buy a Novell server or a Xerox device. Well, in the Infomart, we didn't have to do that. So we could network things from one suite to another. And eventually we put together a building network that made it essentially a connectivity marketplace that people could come in and see how things connected. Well, there came a time when we started connecting Apple to the West Coast, because this whole connectivity idea had really taken off. And the idea of adding a modem, and 9600 baud modems were created by DC Hayes, and suddenly everything started working really well, and we could dial in and we could extend all of that connectivity that we had in the Infomart out to somebody in the field, so they could make a phone call, an 800 number, we set it up, and they could call in and connect. And California said, well, let's take this national or international so we can put this service online other than just our territory. So we were connecting the Apple Market Center to California. And of course, Apple California was connected to the rest of the world. So of course, as things happen, it was either a late Friday night or a Saturday night where you're working, 2 a.m. because nobody's there to be disturbed. We got everything working, and it was time to connect. And if you remember the old Macintosh, they had a thing called a chooser.
Yes.
You've heard that, but basically that was a way of
Mac Plus.
Right. Well, basically that was a way of choosing a network. You could choose a network and then choose resources from within that network. And we had 6 networks in our market center that we could connect. Well, when we connected to California, we suddenly had not only our 6 networks that were in the DFW area,
yes.
but we had everything else on the other Apple network.
Yeah.
And I thought, well, this is really neat. And I started seeing prefixes because Apple prefixed everything with a
country code.
The mail identifier, the airport identifier. I saw, well, there's SYD and there's TOK. And I thought, well, that's interesting. So I asked the guy, I said, what's SYD and what's TOK? He said, well, that's Sydney. I said, really? You mean as in Australia? And he said, oh, yeah, we're connected there too because we have offices in Sydney. And I thought, okay, well, that's interesting. So I had my connection here. And when I plugged the connection in, all of these networks just populated in the chooser, and I could see Sydney and Tokyo. And then if I pulled the cable out, it came right back to our 6 networks. And I could plug it back in, and the entire world would come on. I said, now this is really neat.
It's like
Southern
your
Hemisphere
world expanded all of a sudden.
Oh, I was a god. You know?
Yeah.
Southern Hemisphere online, Southern Hemisphere offline. And then the proof of the pudding was, since everybody trusted Apple, everybody would tend to share with their neighbors. So they would just share their entire disk drive with the adjacent
everybody
machines.
Became a node, and then
it became a node.
Could access everybody else's resources.
So then I thought, well, while they're getting things ready, I just plugged it back in, and there's Sydney. I started exploring desktops, and of course everybody left it open, and I found some files. I didn't do anything malicious, but I found, well, I could take this file and I can put it on my desktop. And I thought, oh, that's very powerful.
Security. Yeah.
No security whatsoever.
No security.
And I can move data 8,500 miles, and I can do it in a matter of seconds. And
nobody would ever know.
Nobody would ever know. And I thought that was so cool. And hopefully my wish for anybody, that's what I find in the Pi and everything else, is that type of excitement. There's nothing easy about any of this, but once you put it together, you come up with some extraordinary results, and you can make things happen, and you understand how the digital world goes together. And there's not enough people that know how to do that. And it's important to understand that, because just to understand where our digital horizons are going to take us, with IP version 6 and Internet of Things, and we can attach virtually everything in the world to a network, and it's somehow monitored. That just is mind-boggling.
The Internet of Things, right? You just described it. Everything.
Yes.
But your story is also very interesting because it shows how things have changed. What your story reminded me of Richard Stallman when I was at the University of Technology, Sydney. Richard Stallman, who is one of the, how would you call him?
That name's familiar.
Well, he is the founder of Free Software Movement, GNU or GNU. So he's the open source god in a way.
Yes.
But I remember his story when he was at MIT working on open source software. Because of the culture there, the idea was that all computers should have no passwords. So a professor's computer should have no password. A student should be able to go use the professor's computer at any time if the professor was not there, because it is a resource that should be shared. So, and that was the how things were done until Unix introduced passwords and started tightening the networks and the security of the networks, because privacy issues came in and commercial issues and all that. And he was talking about all that and all those changes in that lecture that he gave at UTS maybe about 15, 20 years ago. And that's what I was thinking when you were telling us about your experience with the Apple network. And
there's no passwords.
How things have changed. Now, two-step authentication and encryption everywhere, and it's not enough.
And it is a whole career to even understand that. And in order to understand it, you've got to understand why does that LED turn on when I write a program,
And you have
how
to
do
do
I
it
get to it?
securely
Yeah,
as
and you have
well.
to do it securely. We have everything is open right now.
Yes.
It's unprotected. So, but
Great. Thank you.
that's another
Yeah.
piece to
Ah,
travel onto there.
memories. Well, thank you for the story, Richard.
Oh
I
yeah.
really enjoyed it. How can people get in touch with you?
Uh, Probably just use the email.
Email.
I created an email that I kind of use for this sort of purpose, but it's I put it in the profile, but
We'll
parkrb
have it listed. Yeah.
at gmail.com. But
No worries.
if Tech Explorations opens up, has some sort of a venue there, a posting device, put a comment on
Definitely.
the blog.
Yeah, yeah. Well, you
Um,
have your page here, but I hope you can write some more blog posts for us.
what I'm
And
planning on doing is taking the, I'm to a point where I can write up what I've been doing with the TMP 36, and
yeah,
I'm going to create maybe 3 lessons on how
guys.
to do
Yeah,
that.
sure.
And I don't know
That'd be
how
perfect.
you want to present that, but
We'll
uh,
help you out with that.
yeah, I would appreciate that. But
Awesome.
I'm going to learn how to use GitHub a little bit better. So
Oh,
that'll
yeah.
work.
GitHub is an awesome tool. In my new course, I actually use Git, Git, not GitHub, but Git, it's just a user interface essentially
Hmm.
um, built on top of GitHub. But once you know how to use Git, you can use GitHub. And in the latest course that I'm working on now, I'm using Git from day one, essentially. It's not an afterthought anymore or just another thing. So it is powerful for anything to do with software and with text that you want to keep track of.
Okay. Well,
Yeah,
managing the projects is important. Organizing things, comments, and all that, that's absolutely essential.
awesome.
Yeah. Okay.
Well, thank you, Richard. I
I,
really enjoyed our conversation. Thank you for making the time and staying up so late.
I don't have to teach tomorrow, so I can sleep late. Thank
Or
you
we can
for
stay up a
inviting
little
me.
later.
Thank you for inviting me. It's a real honor. Thank you.
Awesome. Thank you.